CQT is a national laboratory of Singapore, and it was created 15 years ago and now totals 230 between students and staff. So its role is not only to develop new basic science, but also to foster the technological transfer between academia and industry. In the many laboratories that we have here, we are running many experiments. For instance, we are using quantum clocks to measure time more precisely than ever. And we are also developing technologies that will allow us to enhance the security of our communications. And this technology goes under the name of quantum key distribution. And then we are learning how to manipulate quantum information by really building quantum computers. This is done by building qubits, which are the fundamental blocks of quantum computers. So this will unlock the ability to build faster and faster quantum algorithms that will have many applications in real life. So writing new quantum algorithms is really my job. And the idea behind quantum computing is to compute something by encoding the input in a quantum state and then evolving the quantum system according to a software, so basically our algorithm, and then measure the system in order to obtain the solution. So the goal is to make quantum algorithms that are faster, better, more efficient than what we can hope to run on classical computers, or maybe a combination of the above. So as a theoretician, I write algorithms mostly in two domains, machine learning and finance. So in essence, machine learning wants to find a sort of synthetic description of a set of data points. For example, in cybersecurity, what we do is we use machine learning to detect anomalies in network traffic. These anomalies can represent attacks or misuse of a network from a malicious attacker. And we try to understand how quantum computers can make us better at this task. So in finance, one of the most iconic problems is to price financial derivatives. And a financial derivative is basically a complex function of the future value of one or more stocks. And the stock value is modeled with kind of the same mathematics that you use to model the behavior of molecules if boiling water in a pan, and where the molecules hit and interact with each other chaotically. Modeling the stock market using this mathematics is a daunting task that requires a lot of computational resources on classical computers. But using quantum computers for pricing derivatives can give an edge to competitors, as you can understand better and faster what are the risks and the value of your investments. So in short, I think that any new technology has the potential to be misused. And so being able to process more and better the information that we produce and the data that we produce every day might amplify the imbalances of power between citizens versus big corporations and governments. For example, a very concrete threat consists in using quantum computers to break the current cryptographic schemes that we use to protect our communications. For example, from our calls to the money in our bank account. And for this, cryptographers are developing new cryptographic schemes that are secure even for quantum attackers. To prevent this, in general, I advocate for starting to understand better the consequences of this new set of technologies so we can be prepared for a quantum future tomorrow. In practice, this consists in developing a framework to regulate the quantum computing set of technologies and also have a clear understanding of the use cases in the business.